is going to be counting significant figures. Okay, so let's talk about why significant figures are so important. Definitely, it's going to make your life easier because, you guys have come across this before. You be calculating a problem, and then the calculator gives you like 15 digits. Am I supposed to write all those 15 digits, you ask yourself? No, you're not. There is a distinct way, there's a method in which you will know exactly to what number to round to, right? And that's considering significant figures, right? So why is it so important? Well, the more significant figures you have, that means the more precise your measurement, okay? So it's a communication. It's a way to communicate how sure you are about the number. Um, so, for example, let's say that you're tasked with measuring your classmate's height, but all you have is a shoe, right? So I give you a shoe and I'm like, measure the person's height. And you're like, okay, so you go, you start with the shoe, right? And you're like, oh, one shoe, two shoe, right? Three shoe, four shoe, five shoe. Okay, that's like half a shoe. You're like, okay. And a shoe is about a foot. So you'd be like, I think this person is like 5.5 foot, right? And that would be the correct number of sig figs, two sig figs, right? 5.5. That would be the correct number because you have no reason to sit there and be like, oh, this person is 5.524 feet. Well, why? How are you getting the other digits, right? You only have a shoe. It is only, it's a very crude measurement. So how did you get the other digits, right? And so it is a communication. What the numbers that you write is a way to communicate how precise the measurement is and how sophisticated your instrument of measure is. So it's definitely very important to take that into consideration in science, okay? And so that's why we're going to go through a series of guidelines, series of rules for you guys to figure out how many sig figs to round to. But before we can do that, we have to learn how to count sig figs, right? So let's go through the rules on how to count sig figs. Let's look at rule 1. All non-zero digits are significant, okay? So that means in the digits 28.03, in this number, the 2, the 8, the 3, right? Although all the numbers in pink are going to be significant, no doubt, right? Because that's what it says. All non-zero digits are significant, okay? In this example, 0.0540, okay, the 5 and the 4 for sure are significant, right? Okay. Because they're non-zero. Okay. So pretty easy rule, right? Rule 1. Rule 2. Rule 2 has to do with the zeros now. Okay. Now the zeros are a little bit trickier, so we're gonna have several rules for the zeros. Maybe you're gonna want to write this down, right? Take notes. So the interior zeros. That means the zeros that are sandwiched between two significant numbers are also significant. I call this rule significant by association, right? Since in the number 408, both the 4 and the 8 are significant, the 0 that's is sandwiched between them by association is also significant, right? That's kind of a way to remember it. In the number 7.0301, okay, both of those zeros are also significant because they are sandwiched in between two significant numbers, okay? This 0 here to the left is a sandwich between a 3, okay, and a 7, okay? So it's going to be significant, all right? Let's go to rule number 3, okay? Now, the leading zero. So we just did interior zeros, right? The leading zeros, they are not significant, okay? And that kind of piggybacks off of rule 2, right? Because a leading zero is not sandwiched by two significant digits. Like these zeros in the number 0.0032, these three zeros don't have a significant number to their left, right? So they're not sandwiched, which means these zeros do not count, okay? So leading zeros don't count. So in this number, if I had to count the number of sig figs, that's just 2. This number has just 2 sig figs because a 3 and a 2 counts, right? This number here, these zeros don't count either. So you just have one sig fig in this number. 0.00006 only has one sig fig, okay? That's rule 3, okay? So it kind of piggybacks off of rule 2, right? It's not sandwich. Now, rule 4 is a little bit more tricky because you have trailing zeros, and there are multiple ways you have trailing zeros. So the first way to have trailing zeros, if the zeros are behind a decimal, then they count. Okay, so you see these 3 zeros, they're trailing, right? They're behind, but they follow a decimal, so they all count. That means in this number, there are 5 sig figs. These 2 zeros, after the 5 and the 6, they also count, right? Because they also follow a decimal. Decimal's right here, right? So in this number, there are also 5 significant digits. Okay. Let's look at this number. This number is 140.00. In this one, the two zeros that's trailing the decimal point for sure, right, is counting. But this 0 in the middle is also counting. And one way to think about that is it's sandwiched between the 4 and the decimal place. Okay, so the decimal place is also significant, right? Or you can think of it as, since these 2 zeros are significant, this pink 0 is sandwiched between 2 significant digits. So by association, it has to be significant, right? So in this number, 5 sig figs total. Let's look at this number, 2500.55. In this number, right, the 2 zeros in the middle have to be significant because it's sandwiched between 2 5s. Okay. So therefore, 6 significant digits total in this number. Okay. All right, now let's look at the trailing zeros that are just hanging there without a decimal, right? So the number like 1200. If you write 1200 without a decimal, these trailing zeros do not count. Okay. So that means the 1 and the 2 is the only significant. So you only have 2 sig figs there. Okay. But try to avoid writing numbers like this. We call these ambiguous. So it's either 2 sig figs or it's ambiguous. We don't know because there's no decimal place, right? So rather than writing 1200, I encourage you guys to write in scientific notation. So use scientific notation to figure out how many sig figs you want to express. So if you want to express 2 sig figs, then you're going to write it as 1.2 times 10 to the third, right? Using scientific notation. If you want to do it as 3 sig figs, then write 1.20, because when you add a 0 here, that number becomes 3 sig figs, right? Times 10 to the third, okay? And then the bottom number, 1.200, okay, that's 4 sig figs. That's going to be, right, because these 2 zeros count now, right? So 1.200 times 10 to the third is 4 sig figs, okay? Now, there's one more way to do 4 sig figs. Just add a dot at the end of the 0. Because as soon as you do that, you have the 2 zeros sandwiched between a decimal place and a 2, right? So those zeros are not going to be significant, okay? Okay. All right. So what I would do is, I know that that's a lot of rules. It may be that you guys have just encountered this. The only way to do this is to practice, right? Go to your homework and practice counting sig figs. Review the rules. Make sure you understand them. And if you still don't, either rewatch this section or come to office hours and I can explain it to you again as well. Okay, so let's move on, right? So for exact numbers, okay, exact numbers have an unlimited number of significant figures, okay? So how can you tell that something is an exact number versus a measured number? Is a lot of it is by context, okay? So exact numbers are going to be exact discrete objects. And for example, that would be like counting people, right? So if I say 7 people, That's not a measured unit because people can't come in half, right? You can't have 1.24 people. So that's how you know that 7 is an exact number. Okay. Another way to know that you have an exact number is if you have defined quantities. So that's something like 1 foot is equal to 12 inches, right? All of those digits are going to be exact, right? Because they're defined. We've defined 1 foot to be 12 inches. Okay. So those numbers would have an unlimited number of sig figs. Okay. Or there's some numbers that are part of an equation. Integral numbers that are part of an equation are also going to be uh, unlimited number of sig figs. Okay. All right. So now we're going to deal with significant figures in calculations. So in calculations, um, you need to, your answer needs to reflect the precision of the measured quantities, right? So you don't want to express your answer to be um, really precise when you only worked with numbers that are imprecise, okay? So there's going to be rules that will tell you where to round, okay? So the key is we should not lose or gain precision during a mathematical operation, right? And so the way that we avoid that, okay, is to use these rules. So let's take a look at this, okay? The multiplication rule and the division rule. So multiplication and division are, one and the same, really, right? So they have the same rule. So whenever you multiply or divide, you're going to round to the fewest significant figure, okay? So you're going to round to the same number of significant figures as the number with the fewest sig figs. Okay, so what do we mean by that? The example will illustrate that clearly. So let's say that we're multiplying these three numbers, right? 1.052, 12.504, and 0.53. Let's count the sig figs for each of them. So for this one, we have 4 sig figs. Okay. For 12.504, we have 5 sig figs, right? And then for 0.53, we have 2 sig figs. Okay. So that means the number with the fewest number of sig figs is 2 sig figs. That means we will round our answer to 2 sig figs. Does that make sense? So it goes by the fewest sig figs when you're multiplying, dividing. So you enter in all these numbers as is into your calculator, and you will get this blue number, right? 6.7208. You should not write this whole thing as your answer because that would mislead people into thinking you have really precise measurement, right? You don't, because one of your numbers only 2 sig figs, right? Not very precise. So that's why you have to round to 6.7. 6.7 is just 2 sig figs. Yeah. Okay, let's look at division, right? So you have this number divide by this number. This number is 5 sig figs. This number is 3 sig figs, right? 3.20. So when you divide that, you will get 0.626094. Don't write all that, right? You're going to round it to the same sig fig as the number with the fewest. That would be 3. So you will round this to 0.626. 3 sig figs. Okay. Okay, let's go on to the addition and subtraction rule, right? So when you add and subtract, it's going to be a different rule. It's not going by fewest sig figs. It's going to go by the number with the fewest decimal place. Okay, so when you have 2.345, 0.07, and 2.9975, okay, notice that the number with the fewest decimal place is 0.07. Okay, so that means because it only has 2 decimal places, right? These numbers have more, so they're more precise. So you always round to the number that's least precise. So that's this one, which is 2 decimal places. That means you need to truncate here, right? So the 5.4125 becomes 5.41 because you need to round to the second decimal place, okay? Then in this problem, when you're subtracting 5.9 minus 0.221, Again, you look for the number with the fewest decimal place. That's 5.9. It only has one decimal place. So guess how many decimal place you round to? One as well. So your calculator gives you the blue number. You round to 5.7, right? Because that's one decimal place. So it says here, right? Sometimes it's helpful to draw this line next to the number so it's easy to see like where you should truncate, but that's up to you, right? I just simply notice like, okay, how many decimal places are each number? And I round to the lowest one, right? The fewest decimal place. Okay, and then let's talk about the rules for rounding too. It's actually a review. These rules are no different than how you learned it in any other class, right? And you guys, have seen this before. Let's say that we are tasked to round these numbers to two significant figures. So that means a 5.37 will round to a 5.4, okay? So the rule is if the number next to that number that you want to round at is 5 or greater, you round up. If it is below 5, then you leave it the same, okay? So then if you have 5.34, right, remember you're trying to round to two sig figs, so you know you have to truncate here at the first decimal place, right? So you look to the second decimal place, oh, that's a 4, it's under 5, so I'm going to leave the 3 alone. So it becomes 5.3. Okay, two sig figs, right? 1, 2, 1, 2. Now 5.35, because the 5 is, a 5, right? You round up, it's 5.4. And even the number 5.349, you ignore the 9 because you're not trying to round at the 4, right? You're trying to round at the first decimal place. So it doesn't matter how many numbers come after, right? All you have to do is look at the 4. You're like, okay, that's 5.3. Okay. All right. Now to the next level, okay? So the next level for sig figs is when you're rounding in multi-step calculations. Multi-step calculations are when you have both multiplication, division, and addition subtraction in your problem, okay? When that takes place, what you're gonna do is you're gonna still use, your math rules of, doing things in parentheses first, right? And then multiplying and so on and so forth. You're still gonna do the same thing, but you're gonna keep track by underlining the least significant digit as you go along. That way, um, you will not have a rounding error. Okay, you still use all the numbers, but you will underline the least significant digit to keep track of, how many sig figs is that number worth. Okay, so let's do this problem together, and it's gonna make a lot more sense. I'm gonna switch to the board for this because it's gonna be easier for you guys to see. Okay, so I'll stop share, go to the board. Let me just copy the problem down. What we got 6.78 times 5.903 times 5.489 minus 5.01. Okay. So what I'm going to do, right, with this problem, apply the math rules. We need to do things in parentheses first. And as we are doing things in parentheses, we also apply the operation that is in parentheses. So it's the subtraction in parentheses. So the rule, remember, subtraction and addition is you're going to go by fewest decimal place. So this has 2 decimal place. This has 3 decimal place. So when I take this minus that in my calculator, I get 0.479. Okay, and you guys can follow along here. But I know that if I had stopped the problem here, right? If it was just this problem by itself, I would have rounded to the second decimal place. So it would have become 0.48, okay? But I can't do that here. The reason is this is a multi-step calculation. So I'm not done with the problem. I should not truncate here. Otherwise, I have a rounding error. So when you're doing multi-step calculations, you want to make sure that you don't round until the very end, right? Until you get the answer. So to avoid doing that, that's why we're going to underline where we would have rounded so that we remember, okay? But we still use these 3 numbers to continue multiplying the other 2. Okay, so we're gonna take 6.78 times 5.903 times 0.479, and we will get 19.1707 on our calculator. Okay. At this point is when we can round because we are done with the problem, right? So what we just did, the operation we just did is multiplication. So we apply that rule. So you guys see, we apply rules as we go along. Since we're subtracting, earlier we applied the subtraction addition rule. Now we're multiplying. So we're going to apply the multiplication division rule, which says we're going to go by the fewest sig fig. This number has 3 sig figs. This number has 4 sig figs. And this number, because we underlined it, actually only has 2, right? So we need to round this to 19. Okay, because that's 2 sig figs. All right. Okay, so let me see here. Yeah, let's look at it again. I wasn't sure if the camera actually caught it. So let me explain that again, right? So we had our original problem. Okay. So what we do first is we do the subtraction first. Okay. 5.489 minus 5.01. And that's going to give us 0.479, right? All right. So, ooh, sorry about that. I didn't realize that my Zoom was recording mirror image. So I fixed that. Okay, so we're gonna go look at this problem again. So we're gonna start at the beginning so you guys can actually see it now, right? All right, so originally we had this problem, right? It's also on the slide, okay? So I know there's a little bit of glare here. But that's 5.489, right? Okay, so we are gonna do the operation in the parentheses first. Okay? But as I was saying, because it's a subtraction, we are going to use that subtraction addition rule, which is truncating at the lowest decimal place, right? Fewest decimal place. So if you subtract this number with this number, you get 0.479 on your calculator. Now, if that was all that it is, you would say 0.48, right? Because this is 2 decimal place and this is 3, and we go by fewest decimal place. So you would have said 0.48, but we're not done with the problem. So if we round right here, we're gonna get big rounding errors at the end. So that's always the rule when you have multi-step calculations, don't round until the end. So this 0.479, leave it as is. However, you're going to underline where you would have rounded. Okay, that's just to keep track, right, of that this number is actually only 2 sig figs. Okay, that's why we're underlining it. Because now when we go and we multiply it by these two numbers, now it's multiplication division rule, right? Which is going by fewest number of sig figs. That's 2 right there. Okay, so when you get this number on your calculator, you're going to round to 19 because that's 2 sig figs. Right? Does that make sense? All right. Okay, let's go back to our PowerPoint here. Okay, there we were. All right, so we'll continue. All right, so let's practice a little bit, right? Let's practice, and here's where you can pause, right? Because I'll ask the question, then I'll give the answer. So you guys pause and then figure out how many sig figs are for each of these numbers, right? Then you can check your answer with me, okay? So how many sig figs are there in A? This number right here, 0.04450 meter. Well, first of all, by meter, right, that's this unit, I know that somebody had to measure it. So there's going to be an error associated with it. Okay, so therefore, it's not an exact number. Okay, that's how I can tell it's not an exact number. So therefore, it will have, I can count sig figs for it, right? This one has 4 because the leading zeros don't count. Okay, but this 0 does because it comes after a decimal. Okay, so 4 sig figs for A. Now I go to B, 5.0003 kilometers. Oh, kilometers of distance. So I know there's error associated with that because somebody had to like take a meter stick or something, right? Some measuring device to measure it. So it's a measured quantity and it's not an exact quantity, okay? So then I can, again, I don't say it's an exact number, right? I count. It's actually 5. Why? Because these 3 zeros are sandwiched, right? They're interior zeros, so they count. 5 sig figs for B. Then for C, oh, this is interesting. It's an expression. It's not just a number, right? It's 10 decimeter is equal to 1 meter. This is what we call a defined quantity, right? Because we are defining, right? That in 1 meter, there's 10 decimeter. So we're not measuring anything, right? We're just defining it. And so that's how we know that this is an exact, all these numbers are exact. So remember, exact numbers have infinite significant figures. Okay, so C, infinite. D, we have a scientific notation number, 1.000 times 10 to the 5th second. So again, second means it's measured, right? So it's not exact, okay, it's a measured. So we can count it. Now, with scientific notation number, don't worry about the times 10 to the. We're just going to look at the base for sig figs. So that's 4 total because these 3 zeros occur after a decimal. So remember that. Those zeros count. So 4 total for D. Okay. Then for E, you have 0.00002 millimeter. Millimeter, that's a measured value, right? Millimeter, somebody had to, again, take out a ruler. So there's error associated with that. It's not an exact number. So 1 for E. Why? These leading zeros don't count. Remember, leading zeros don't count. Okay. Then for F, 10,000 meters. So 10000 meter. Okay, we know it's not an exact value because meter means somebody measured it, right? It's a measured value. But here we would say it's ambiguous, right? There's no decimal place. We don't know what the author means by writing this, right? They're not being very clear about how many sig figs they want to express. So if we want to be strict about it, we can only say 1 because remember, these trailing zeros without decimal, they don't count. So it's only the one that counts, okay? So you have to be strict about it. You say, that's just 1 sig fig, okay? Or you can say ambiguous. Okay, let's keep going. This other practice problem, right? 554 kilometers. Okay. Kilometers, again, that's a measured value. 554, that's 3. Yeah, that one's easy. Then B, 7 pennies. Well, here's context. Pennies don't need to be measured. Like, you don't need to go and get a ruler or something like that to measure 7 pennies, right? It's a discrete amount that you count. You can't have half pennies, right? And you can't have like 1/4 of a penny. So 7 pennies, by context, you can say that that is an exact value, right? There's exactly 7 pennies, unless somebody doesn't know how to count, right? But we're not going to assume that. We say, okay, that's not a measure value, that's exact. So it's going to have unlimited amount of sig figs for a B. For C, we encounter another scientific notation number. So we're only going to look at 1.01, right? And here's its meter, so we know that it's a measured value. So we can count, right? 1.01 is 3 because that 0 in the middle counts. It's interior 0. It's sandwiched between 2 sig figs, so 3 total. Okay. Now for D, you notice in the unit again, right? Seconds. That means it's not exact, right? Somebody had to measure it. And here, the zeros don't count, so it's 2 sig figs. Okay. In E, 1.4500 kilometer. Again, we see kilometer is a measured value, right? So it's not exact, so we count. I count 5. You know why? these two zeros occur after a decimal. So they do count, right? 1.4500, 5 digits. F, oh, it's the same. Okay, so we just move on. I think that's a typo. Okay, let's do this one together. Okay, so now we're gonna do sig figs and calculations. We get more practice with this. Okay, so I'm gonna, this is a point to where you can pause the video and work out these problems for yourself, and then resume the video because I'm gonna work out these problems for you right now. Okay. Again, I'm gonna turn off my my share screen, and then I'm gonna go to the board so you guys can see this better. All right. Let's erase this. Let's do A first. So, um, for A, we have 1.10 times 0.5120 times 4.0015 divided by 3.4555. Okay. So when you look at this problem, right, assess it first. I'm like, oh, I only see multiplying and dividing. So that's just one rule, which goes by fewest number of sig figs, right? So this one has 3 sig figs, right? I can make a little note to myself. This one has 4 sig figs, okay? This one has 5 sig figs, and this one has 5 sig figs. So which number has the fewest? It's this one. And how many does it have? It has 3. So that's how I know I'm going to round my answer to 3 sig figs. So all I have to do now is punch this into the calculator. I'll tell you what my calculator says. It's 0.65219. Okay. And now I know I have to round to the to match the number with the few sig figs. So that'd be the one with 3. So I'm gonna round to, I need to round to the third decimal place. So I look to the 1, so that's gonna keep the 2 the same. So my answer is 0.652. And I always circle my answer. You guys should do that too, right? Especially on exams and quizzes. So it's easy for me to grade. Okay, so you guys see how that works, right? Just applying one rule here because we're only doing multiplying and dividing. All right, let's do B. B is 0.355 plus 105.1 minus 100.5826. Okay. So now I assess again. I'm like, oh, I'm only, adding and subtracting. So I'm going to go by the number with the fewest decimal place. This one has 3 decimal places. This number has 1 decimal place, and this one has 4. Obviously, we need to round to this number because it only has 1 decimal place. And how do we round? Well, obviously, to 1 decimal place. So just punch that into your calculator. You will get 4.8730. Okay. And so you need to round to the first decimal place. So you're going to look to the second decimal place, which is a 7, and now turn the 8 into a 9. So you're going to round up, right? So there we go. Rounding to 1 decimal place. Okay. All right. Let's do C. Copy it down first. It's exactly as on this slide. Okay. So you can look at that as well. Okay, so here we have this, right? So we can see that this is like a a mixed media kind of problem, right? So to speak, because you have both multiplying, dividing, and also, subtracting and addition, right? So we know now this is going to be a problem like we did earlier, where we have to keep track of where we would have rounded, right? Don't round early. And so we just follow our math rules, right? Always do things in parentheses first. So when I take this number, subtract this number, my calculator is going to say 0.3455. Okay. Now, if I was done with this, I would have rounded to the second decimal place, because remember, subtraction rule is fewest decimal place, and that would be this number, which just has 2 decimal places. So I would have truncated here, but I'm not gonna do that, right? Because I'm not done with the problem. So all I simply do is just underline it. I would have truncated it there. And then I proceed on with my life as usual. So now I'm gonna multiply these two numbers and then divide by 0.3455. Okay? So in your calculator, just punch that. This times that, divide by that, and you will get 52.79904. Okay. So this will become, because we're multiplying and dividing, we have to go by fewest sig fig, right? Which one has the fewest sig fig? Well, this one has 4 sig figs. This one has 6. And this one only has 2. How do I count that? Because remember, I underlined here. That's 1, 2. So that only has 2 sig figs. I need to round this to 53, right? Because that 7 rounds to 2 up. 2 sig figs. Okay. All right, let me erase this, and then I'll show you guys D. So for D, let me copy that down. 14.84 times 0.55 minus 8.2. Okay, so again, we see that it's a mixed problem, right? You have subtraction, you don't have multiplication. So I'm going to do the thing in parentheses first. Okay, that's going to give me 0.142. Okay, and then what should I underline? Well, since we're multiplying, right? We just did multiplication. We need to think about the fewest sig figs. This number has 4 sig figs. This one has 2. So I need to underline at the second sig fig. Okay. And then I just move on with my life, and I subtract 8.02. So that's going to give me 14.84. Let me see. Oh, sorry. Let's do that one more time. So 14.84, brain fart there. 14.84 times 0.55 should give me 8.162. Okay. And then again, right, I need to underline at the second, right? Two sig figs. So that'll be here, the second number. Okay, because I'm multiplying, right? So I go by fewest number of sig figs. That's 2. So I underline the 1. And then I move on with my life and subtract minus 8.02. And then this will give me 0.142. And then I'm like, wait, I just did subtraction. So I need to go by fewest decimal place. And my fewest decimal place is, this one has 2 decimal places, and this one only has 1 decimal place. So I need to round this to 1 decimal place. And therefore, it's just 0.1. Okay. All right. So, I know that this is new, and it's just gonna take practice, right? I can do a lot more problems for you, but you gotta go and do a few for yourself, and just practice it, right? So let's go back to the slides, and I'm gonna show you. Right, there's some more practice here that you guys can do. So that's what I would do, right? Go and try to knock out those problems. And then if you need